No, sir.
Fine. Now, that means this is no longer 1, this is now 0. Now, what will happen to the output? Q1.
0.
No, Q will be,
Sir, 1.
Oh, yes, sir. 1.
this one will come here, and Q1 will be 0. Fine. So, as soon as the clock becomes 1, as the data input was 1, I am getting the output to be 1. Okay. And this continues so long as my D in is 1. As soon as D in becomes 0, somewhere here, this is 0. So what else changes will happen? Changes will start from which which output?
The 4.
Sir, 4.
So this will be
1.
the output 1. So this one will come here, and that one will definitely also come here. Okay. Oh, by the way, that 0 should have propagated here. Isn't it? This earlier 0 of this node should have propagated there. Is it not?
Yes, sir.
So now
Yes,
what
sir.
will happen? Will there be any change in output of NAND gate 1?
3 te change hoga, sir.
In NAND gate number 1, will there be any change?
No, sir.
NAND gate 2?
No, sir.
NAND gate 3?
So it will become 0.
Why?
1, 1, 1.
No, it is not 1, 1, 1. It is 0, 1, 1. The first input of NAND gate number 3 is coming from this node, na?
Acha,
Yes, sir.
yes, sir.
Yeah, that is 0 here. So that output of NAND gate number 3 will remain 1. It will not change. So what happens to the output? Will there be any change?
No change, sir.
No, sir.
So the output remains 1. Now here, input once again goes to 0. Oh, sorry, 1. So what will be the changes?
Sir, for NAND latch
4.
4, it will be 0.
It will be 0. That 0 will be coming here. That 0 will be coming here. So that will end. And what about the others? I think others will remain the same.
Yes, sir. Others will be same.
Others will remain the same. That means the output will remain that in logic 1 condition. When clock becomes 0, again, so what happens? Irrespective of the other conditions, these two will become 1. Is it not?
Yes, sir.
Now, this one will definitely come here. This one will definitely come here. Fine. Anything else? No. Now, in the meantime, my D in had become already 0. So this was already 1. So that 1 is supposed to be available here as well as here. So this NAND gate inputs are 1, 1. So output must be 0. So this is 0. Here also it is 1. Clock is 0. So these two are already 1. So that's the situation. Okay. So once again, when the rising edge of the clock comes, then you will find that as this is 1, this is 1. Let me draw it again. Otherwise, I don't think you are able to perceive anything. So when I am in this condition, so that means I am this state. Prior to the arrival of this clock rising edge, clock was 0, data input was already 0. So what happened to the outputs? This 4 was 1. Then 3 was already 1. So that was the situation. And what about the output? Output is 1. Okay, prior to the arrival of the clock rising edge, this was the situation. So when the clock rising edge comes, this becomes 1. So this is 1, this is also 1. So what changes are you seeing at the circuit?
And latch 3 will become 0, output of it.
0. So this will be 0. Okay, fine. Anything, any other change? In the first stage? In the first stage, will there be any other change?
No, sir.
Now in the second stage, what will happen? The Q bar will become
1.
1.
so that will come here and this will become 0. So what we find is from this circuit, what we find? We find that the output follows the input signal only at the rising edge of the clock. When the clock remains high or when clock remains 0, there is no effect of any input change at the output. The output will start following, output will follow the input only when the clock rising edge comes. So in effect, this memory element is nothing but one flip-flop type of memory element because the output responds to the input condition only at the rising edge of the clock. So this is a rising edge sensitive flip-flop. And whatever flip-flop, not D flip-flop. So have you understood this particular circuit configuration?
Yes, sir.
Yes, sir.
So this among the flip-flop internal circuits, the D flip-flop is the only one which can be perceived quite easily. But about the others, I cannot say about that. See, if you go to the data sheet of any JK flip-flop or SR flip-flop, you'll find that that's a quite complex one, and there are a lot of different types of feedbacks are involved. Here I have two different feedbacks. One is this feedback, and the second one is this feedback. Apart from the internal feedbacks of the latches, latches তো আমার একটা internal positive feedback রয়েছে. Apart from that, amongst this NAND latch and this NAND latch, I am having two special type of feedback. One is coming by this side, and the other one is coming by this side. So this special type of feedback is used to incorporate edge sensitivity at the output with respect to the clock. In the case of SR flip-flop or JK flip-flop, the flip-flop structure is the feedback structure is more complicated. This is a very difficult to understand at a very first sight. Definitely, one can understand that, but it is not so easy. So I'm not going for those details. I have just given you one only brief introduction of the internal circuitry of one type of memory element, one type of flip-flop type flip-flop, that is the D flip-flop. Now here, if I have to introduce the asynchronous preset clear, where should I introduce them?
Second stage.
Second stage. That means here as well as here. One will be preset bar, the other will be clear bar. Okay? Have you understood that?
Yes, sir.
Fine. Now, I'm going to describe the excitation tables for different flip-flops. Now, what do I mean by excitation table? Here I have drawn the block diagram of one SR flip-flop. Now we have already studied the truth table of SR flip-flop. Where in the left-hand side, what do we have? The input combinations, S and R. In the right-hand side, what do we have? Now output, Qn plus 1. Now when SR are 0, 0, Qn plus 1 is Qn. SR is 1, 0, the memory is set. SR is 0, 1, the memory is reset. And for 1, 1, that is not allowed. So that's the truth table of SR flip-flop. Now, it may so happen that the output should change from logic 0 state to logic 1 state. Now, it is the excitation table which describes for which input condition this particular type of output state change may occur. I repeat. Say the output has to have has to ensure a state change from logic 0 to logic 1. Now, to initiate that particular state change, what type of input I have to provide? That is being given by the excitation table. How many different types of state changes may occur?
Two.
Two.
Kiki?
So 0 to 1 and 1 to 0.
It may so happen that I want to continue with the previous state. Output was previously 0. The next output should also remain 0. That is also one type of state transition. Output was previously 1. I may want to continue with that same state in the next state. So 1 to 1 transition, 0 to 0 transition, 0 to 1 transition, and 1 to 0 transition. These are the 4 different state transitions that are possible. From one clock active age to the next clock active age. At the clock active age, there was the output was 0. In the next clock active age, I require the output to remain 0. So for that, what type of input I must provide? Similarly, at one clock age, I was having logic 1 output. In the next clock age, I require a logic 0 output. So what is the input excitation that I have to give? What input condition I have to provide? That is, what is the input excitation I have to give? Okay, so altogether, how many state transitions are possible? No, 4.
4.
4, sir.
This is previous state. This is the next state. Previous state was 0. The next state requirement is also 0. So what should be my S value and what should be my R value?
0 0 or 0 1.
What should be my S and R value?
0 0 or 0 1.
I know, Parvez, you are following before my class. You are following the class note from Arjuna. So please let the others answer.
So 0 0 or 0 1, sir. Because
Why?
so for 0 0 0, the previous output will
But the
prevail.
why it should be 0 0? First of all, it will continue the previous one. Fine. Yeah, that's one condition.
Yes, sir.
What might be the others? What is the others excitation and why?
So if it,
You have told that it is 0 1. Then why? If we apply 0 1 input
so
condition,
for 0
what
1
happens to the
also,
memory?
the output will be 0, sir.
Why? Why? Why are the output should be 0 for the 0 1 input condition? The memory is
Reset.
resetted.
Reset, yes, sir.
Okay, so I may come to the logic 0 output from logic 0 output itself by continuing with the previous state or by resetting the memory. Is it not?
Yes, sir. Got it.
In the next state, I may arrive at the logic 0 output from the last logic 0 output itself by continuing the previous state either or by resetting the memory. So that means this 0 0 is for your continuing the previous state and 0 1 is resetting the memory. So that implies what? That implies that my S must be 0. What about R? What about R?
So it can
Does
be
it
0
equal
or
0
not.
0? Does it require one value particularly?
No, sir.
No, it can be either 0 or 1. Doesn't matter. But what about S? What about S?
Sir, it has to be 0.
S has to be 0. So the excitation required is 0 or is don't care. Does not matter what may be the value of R. Then 0 to 1. How is it possible?
Zero.
It is possible only by setting the memory. There
Yes,
is
sir.
remember there is no toggling condition in SR flip-flop. So I can only arrive at logic 1 output from the logic 0 output by giving the input condition which ensures setting the memory. To set the memory, what should be the S and R values?
1 0.
1 0.
1 0.
Next one. It should be easy.
0 1.
0 1. 0
What
1.
about what about the next one?
D 0.
1
0 0.
0 0 is one situation, and is there any other possibility?
By setting the
By
memory.
setting the memory. To set the memory, what input condition do you require?
1 0. 1 0.
So what do we find? Is there any specific value of S?
No, sir.
No, sir.
No.
D 0.
There is a specific value of R. That R should be 0, but S may be of any value.
Don't care.
Yeah. So this is the excitation table for SR flip-flop. Now let us go for the JK. Was 0 to 0.
Zero 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 one.
That means by continuing in the previous state and by resetting the memory.
Resetting.
So what is the J condition and what is the A condition?
0 D.
Next is 0 to 1. How can I do it?
1 0.
By setting the memory.
Or
Is there
by
any
toggling.
and by
Toggling.
toggling. That is what should be the constant input then?
1 1.
1 D.
1 1. So there is once again no specific value required for K. K may be of anything. If my J is 1, that will be sufficient. So required acceleration is 1 D. What about 1 to 0? By resetting or by toggling? Is it not?
Yes, sir.
Yes, sir.
So the condition is D1. Now 1 to 1. By continuing with the previous step 0 0 or by setting
Or by
the
setting-
memory. So that means D0. Okay. কারো কোনো প্রবলেম হচ্ছে বুঝতে? Next, D flip-flop. What should be the excitation for the D flip-flop? How does the D flip-flop functions?
It acts as a data buffer.
That are fine. How it responds to the input?
So same input.
The input will be same as
That means at the arrival of the clock active age, whatever input value is available, that should be your output. Is it not? At the arrival of the
Yes,
clock
sir.
active age, whatever input value is present, that should be copied as the output. Is it not the way the D flip functions?
Yes, sir.
Yes, sir.
So, what is my requirement? My requirement that at the clock active age, my new output should be 0 or 1 or 0 or 1. Is it not? For the four different input type of state transitions. For the 0 to 0, what is the required output? For the 0 to 0 transition, what is the required output?
0.
0.
For 0 to 1 transition,
1.
1.
1 to 0 is 0, 1 to 1 is also 1. So these are this 0, 1 and 0 and 1. They are the required outputs at the new arrival of the clock active age. So what should be the corresponding inputs given there?
Same.
0, 1, 0, 1.
0, 1, sorry. Fine. Now go to the T flip-flop, the final one. By T flip-flop, I mean that T flip-flop which has two inputs, T and the clock. I am not talking about the T only flip-flop. In the case of T only flip-flop, whenever the clock comes, there it will go on toggling. I am not going for that one. I am going for the standard T flip-flop. When your the type of state transition required is 0 to 0, what should be the value of T?
1.
Yeah, why?
0.
Why 1?
0, 0.
Right with toggle. So
How does the T flip-flop function? You tell me, how does a T flip-flop function?
if A is 0, it will be Qn. If A is 1, it will be Qn bar. It will toggle once.
এ নয়, আমার এখানে ইনপুটটা আমি বলবো টি। সেটা আমি যখন সার্কিট ডেসক্রাইব করেছিলাম আমি ওই এ বলে শুরু করেছিলাম বলে তাই। দেখো টি ফ্লিপ ব্লক ডায়াগ্রাম যেখানে সেখানে কিন্তু এ বলে কোনো ইনপুট টার্মিনাল নেই। আচ্ছা কি? ওখানে টি একটা ইনপুট টার্মিনাল আছে, ক্লকের ওই এজটা আছে, আউটপুট আছে দুটো কিউ কিউ বার। So when my t is 0, what happens to the output?
It will continue, remain the same.
Continue the previous.
The last.
When t is 1, what happens to the output?
It will toggle.
It will toggle. Now when your required transition is 0 to 0, out of those two functions, which function has to be implemented by the T flip-flop? State continuation or state toggling?
State continuation.
State continuation. So to continue the previous state, what excitation you should give at the T input?
0.
0.
বাকিগুলো নিশ্চয়ই খুব সোজা বলে দিতে পারবে। 0 to 1?
1.
1.
1, because you do need toggling. 1 to 0?
1.
1.
Because once again you do not need toggling. 1 to 1?
0.
0. Because there is no toggling required, only continuation of the previous state is required. So this is the excitation table for all the four standard flip-flops. JK, SR, D and T. You should remember this thing. Otherwise, when you are going to design, every time you have to realize what is the excitation table. But try to memorize this table. For 0 to 0, SR required is 0 D, 0 to 1, 1 0, 1 to 0, 0 1, 1 to 1, D 0. Similarly for the JK, D and T. Okay, fine. Let us go for one sequential circuit design problem. I want to realize one sequence detector circuit. It has one input X and one output Z. At every clock edge, a single bit X is entering into the circuit. The purpose of the sequence detector is to detect the presence of this particular sequence 1001. And when this 1001 sequence is detected, output Z will be set 1. And in absence of this sequence, output will remain 0. Is the problem clear?
Yes, sir.
Fine. Now say my X. I think similar to this, some other description I have given earlier. Have I
Yes,
not?
sir.
Sir, at every rising edge of the clock, one bit is entering.
Yeah. At every
Okay.
rising edge. That means at the first rising edge, I am getting this, then here, then this bit. This way, it is the input sequence is coming.
Okay, sir.
Now, when the first 0 comes, what is the inference that the sequence detector draws? You place yourself as the sequence detector and assume that you are the person who is going to say that whether the sequence is received or not. The sequence is completely received or not. And do remember that you have got to know prior information about the bits which are going to come. That means when you are observing this particular bit, you have got absolutely no idea what next bits will be. But you do have idea about the previous bits because they are already available with you. Okay, so place yourself as in the place of the sequence detector and try to draw inference at every clock edge. So at the first clock edge, what will be the inference? My inference is my available X bit is 0. So what inference will draw?
First bit
No
was
bit
detected.
of
No
Can
bit.
it be a part of the sequence, this 0?
no.
So the no bit of the sequence is available. In case no bit of the sequence is available, can the output be 0? Can the output be 1?
No.
No.
So the output happens to be 0. When the next rising edge comes, I am getting another 0. So what will be the inference?
No
No
bit
bit
of the sequence
available.
has been detected.
Fine. Then,
First bit of the sequence.
so at this rising edge, I am getting a 1. I know that my sequence starts with 1. So as the previously obtained bits were not part of the sequence, this may be the first bit of the sequence, but is the sequence complete?
No, sir.
No.
So the output has to be 0. What about the next one here?
স্যার এই
First bit.
ইনপুট আর আউটপুটটা কি সাইমultaneous যাচ্ছে না আগে সিকোয়েন্সটা ডিফাইন করা হয়ে গেছে?
আমি কি বললাম? এখানে একটা ক্লক এজ এসছে, এখানে একটা ক্লক এজ এসছে, এখানে একটা ক্লক এজ এসছে, This is the thing that you are getting. Do you still have any confusion?
ইয়েস স্যার, মানে আমি বলতে চাইছি এক্স এর যে পুরো সিকোয়েন্সটা এটা কি আগে দেওয়া হয়েছে, না এক্স যেমন যেমন দিচ্ছে আমার জেডটা
তোমার
তেমন?
কি বললাম একটু আগে, আমি এর আনসার দিয়ে দিয়েছি। অনিন্দিতা কি বলেছিলাম আমি?
Sir, at every rising edge, one bit is being detected.
তারপরেও আমি একটু বলেছিলাম, after saying that you have to assume that you are performing about the you are working in place of the sequence detector,
You don't
and
know the
at every time instant at the rising edge you are having one particular x, and do you have any idea, any prior idea about the next x bits?
No,
Do
sir.
you have that?
No, sir.
Do you have the idea about the previous bits?
Yes, sir.
So you have the idea about the previous bits and the present bit. So can you have any idea about what will be coming in future?
No, sir.
আচ্ছা
So
স্যার,
এবার তো তোমার তো আপনার কনফিউশন ক্লিয়ার হয়েছে?
হ্যাঁ স্যার, হ্যাঁ।
Fine. So when this particular one comes, what is the inference?
First bit.
This once again the first. Now I have previously available bits as 0, 0, 1. So when I am at this particular time instant, I know that one bit of the sequence was already available, and that bit happens to be a 1. If a next bit which follows this particular one is also a 1, then I must say that the previous one was not a part of the sequence. Definitely was not a part of the sequence. Is it not? দুখানা 1 দিয়ে তো কোনো
Yes, sir.
sequence আমি পাচ্ছি না. So the previous
No,
one
sir.
must be discarded. But I cannot say about my future bits. So whatever I have with me now, from that I can draw one inference that this present one is the first bit of the sequence. So here also once again my inference is this has got to be the first bit of the sequence. When the next clock age comes, I am having a 0. So what will be the inference?
Second bit of the
bit
sequence.
detected.
This is the second bit of the sequence. So when you go to the next state, or what is the past history that you have?
2 bits detected.
2 bits of the sequence are already available. So with that past history, I am going to the next time instant. So there, what you are getting? 0 or
First
1?
bit again. 1.
1. So I know my required sequence is 1001. So and I know that the first 2 bits were available. So 10 was available. Now if a 1 follows this particular 10 pattern, that implies that previously available 10 pattern cannot be part of my sequence. So I must discard that part, and I must start afresh that my present one has got to be the first bit of the sequence. Okay. Next, here.
Second bit.
First 2 bits are available. Second bit of the sequence. Here.
Third bit.
No bit available. Sir,
No,
third
no.
bit. Yes, sir. Third
This
bit,
is
sir.
first bit of
Yes.
the sequence. Here.
No bits available.
No bit available.
This 0 has got to be one out of sequence bit. This 0 cannot be part of the sequence.
First bit.
First bit. Second
Second.
bit. Sir, third bit. Sequence has been detected.
Sequence is complete. So I'll be getting a 1 here and 0. Okay. Now when I come here, what will be your inference?
No bit detected.
Anybody is differing?
Second bit Second bit of the sequence.
So two different answer is coming. Two different answers are coming. One is it is not a part of the sequence. The second one is this is the second bit of the sequence. Both might be correct, provided the first one is correct, provided I am not allowing overlapping between the sequences. If I do not allow overlapping between the sequences, in that case, Shuddha Satya is right. But in case I allow overlapping in between my sequences, in that case, Parvez is also right. If you do not allow overlapping, that means I have one sequence. So this is a sequence, and if I allow overlapping between two sequences, this can be considered to be another complete sequence. Is it not?
Yes, sir.
একইভাবে my sequence detection detector যদি এটার জন্য হতো, if the sequence that needs to be detected is 1010, in that case, if we allow overlapping, this will be one sequence, this will be the second sequence, this will be the third sequence.
Sir,
But if you do
third
not-
one
বলো
স্যার থার্ড ওয়ানটা যখন আসলো তখন মানে স্যার দুটা ইনফরমেশন হবে না সিস্টেমটার কাছে কি দিস দ্য ফার্স্ট বিট এন্ড দিস দ্য থার্ড
accordingly
বিট
you have to decide about your states in the state transition table. I'll come to that. I'll come to this specific problem again for 1010 pattern, how it should be handled. But apparently this can be one sequence if you allow overlapping. But if you do not allow overlapping, in that case, this will be one sequence, this will be the second sequence. Is it not?
Yes, sir.
Yes, sir.
So if you allow overlapping, I'll be getting a 1 here, I'll be getting 1 here, and I'll be getting 1 here. 0, 0. Okay, and if you do not allow overlapping, I'll be getting 0, 0, 0, 1, then 0, 0, 0, 1. Okay, is it clear?
Yes, sir.
Fine.
Yes, sir.
So now Joydeep has to decide whether he will allow overlapping or not. কোথায় গেল?
এখানেই
পালিয়ে
আছে
হ্যাঁ
না না
বলো।
পালাইনি স্যার
অ্যালাউ করছো কি করছো না?
অ্যালাউ করছি স্যার
অ্যালাউ করছো, তার মানে তুমি পারভেজের সঙ্গে গেলে।
হ্যাঁ স্যার পারভেজের সঙ্গে
হ্যাঁ, শুদ্ধ সত্যি কিছু করলে জানি না আমি।
স্যার শুদ্ধ সব তো অ্যাক্টিং করবে
ও, ঠিক আছে। So in that case, this when this next 0 comes, this should be the second bit of the sequence. Output is 0. Then this should be,
Third bit, sir.
then sequence is complete. Then here,
Second
bit.
Second bit.
what about here?
First bit.
First bit.
Here,
Second bit.
second bit, third bit,
Third.
sequence complete.
Detect.
Sequence detected complete. তারপর এখানে
second bit,
Second
সেকেন্ড
bit.
বিট
তারপর
Third bit.
তারপরে
no bit.
No bit available.
out of sequence bit, or the no bit of the sequence is available. Okay, so how many at every time instant, how many possible histories you are finding?
4.
কি কি?
So no bit, first bit, second bit, third, no. No bit, first bit, second bit, third bit, and sequence detected.
So how many? Follow.
5.
5. So there were altogether 5 histories, 5 possible histories. First history is no bit of the sequence is available. Second one is first bit of the sequence is available. First 2 bits available. First 3 bits available, and sequence is already completely available. So that's the situation. So these are the possible history at every time instant. So given, by the way, is this one combinational logic circuit design problem or sequential logic circuit design problem?
Sequential.
Sequential, because at every time instant, the output does depend on the past history of the circuit. So here, for every sequential logic design problem, the first thing is you have to identify the states of the possible history of the circuit. You have to identify the possible history information of the system, digital system. So in this digital system or digital circuit, I find that altogether there are 5 possible histories. And those histories are being termed as A, B, C, D, and E. So A stands for the history information which states that no bit of sequence is available. B, 1 bit of sequence is available. 2 bits. Oh. Sequence complete. Okay, so these are the 5 possible histories. These 5 history, what is the relationship between the history and the state of the circuit?
History is present state.
No. What is the relationship between history and the state of the circuit? এক মিনিট আমি আসছি। কোন জায়গায় ছিলাম আমরা? The relationship between the history and the state of the circuit.
History A to D 0 or E to 1?
No. The thing is that the states are the binary encoded history. When you encode any state using a binary code, that becomes a state. History ta ki? Amra natural language, I described that in natural language. State A, history A is nothing but it says that no bit of the sequence is available to the circuit. So it is not binary. It is in natural language. But the digital circuit cannot understand the natural language. It can only understand the binary language. So how many states are there?
5.
5.
5.
So
So
each state আর আগের স্টেটটা কি সেম না ডিফারেন্ট?
বলো, আমি বুঝতে পারলাম না বাবা।
স্যার আগে যে আমরা স্টেটের জন্য টেবল লিখলাম ওই স্টেট আর এই স্টেট কি সেম?
I'll come to that. That was the state of one memory element.
আচ্ছা আচ্ছা।
This is the state of the memory element. Memory element state টা কি? 0 না 1? Okay. Now I'm talking about the state of one sequential circuit, sequential system. Okay. So that state is nothing but the binary encoded history. So how many histories are there?
5.
5.
5. So how many state codes should be there?
5.
5.
5. To encode this history information to 5 codes, how many minimum number of bits would be required?
3.
3.
3.
So using 3 bits, how many codes you can generate?
8.
8.
8. So out of those 8, you can assign any pattern to any of these states. That's up to you. So এবার আবার সেই আমার জয়দীপ, স্টেট এর জন্য কি কোড অ্যাসাইন করতে চাও? এগুলো সব শেয়ার বলে, ক্লাসে অন্য কেউ করে না।
আমার ছাড়া বাকি দুটো শেয়ার করে চান্স দিন স্যার।
না, তারা আমার সঙ্গে যোগাযোগই করে না। বলো।
আর কি বলবো স্যার, এটাতে কি জিজ্ঞেস করলেন, কি বিট দেবো এটাতে?
হ্যাঁ হ্যাঁ, আমার 3 বিটের তো কোড।
স্যার 010।
ফাইন। তারপরটা?
তারপরটা 001।
তারপর
100।
তারপর
101।
তারপর
111।
ফাইন। ফাইন। দ্যাট মিনস আমার 000 কোনটা ইউজ করি সেটা দেখছি আমি। 010, 011 আর 110, এই চারটা আমি ইউজ করি। চারটে কেন?
স্যার 010 ইউজ করেছে।
ইউজ করেছি। তো এই তিনখানা আমি ইউজ করছি না, ঠিক আছে? ফাইন, there is no problem. Given one sequential logic design problem, you have to first identify from the problem description, you have to analyze the problem, and then you have to first identify the all possible history information that are possible for the circuit. After identifying that, you have to assign binary codes for each of them. The next task is to design one or realize one state state transition diagram. This pictorially, you have to describe how the states are transiting from, how the system is transiting from one particular state to another particular state. So in natural language, how the digital system is transiting from one particular history to the next particular next one possible history. So initially, the system should remain in which particular state or which particular history at the very beginning?
010.
010.
Let us forget about the codes. Let us talk about the history. There's natural language description.
No bit detected.
No bit is detected. That's the state code A or the state A. Then there should be one state B. Then there should be one state C. Then there should be one state D. And there is one state E. Okay. Initially, I am in state A. Now the state codes, if you insist, I will give that it is 010. কি বলেছিল ভুলে গেছি গো বাবা, একটু দেখে বলবে এ স্টেট কোডটা কি ছিল?
010
010. B
B হয়তো 001 ছিল।
001
C
100
D 110 ছিল নাকি?
101
101
111
তারপর এটা 11
D টাকে ভুল লিখলাম আমি।
Yes, yes, ওটা
101 হবে।
ঠিক আছে। Okay, fine. Now you are initially in state A. Now how many different input combinations are possible at this state?
Two.
Two. What are they?
0 and 1.
So when you are in the situation that with me there is no bit of the sequence available, now I am waiting for the one particular input bit. How many different types of input may come? Two. Either 0 or 1. Now that what is the input variable name as per my logic circuit block diagram?
X.
X.
What is the output variable name?
Z.
Z.
Okay, so then that means when you are in state A, the two possible values of x are x is equal to 0 and x is equal to 1. Now you may say that my input is x is equal to 0. You may say that my input is x is equal to 1. But instead of that, in the state transition diagram, what we do is we say that the input is x bar or input is x. If I say that my input is x bar, that implies my input is x is equal to 0. If I say that my input is x, that I imply that my input is x is equal to 1. Okay, so when are you in state A, the two possible inputs are x bar and x. When the input is x bar, what happens to the next state? A only, because what do you mean by the next state? That means, say, here you are in state A. The input condition is 0. When the rising edge comes, my inference is this present 0 is also not a part of the sequence. Is it not? When this rising edge comes, my inference is this present 0 is not part of the sequence. So when you will be arriving at this particular time tick, what should be your past history? Were you having any bit of the sequence? I was not having any bit of the sequence. So my new state should be A once again. Okay, so when the input condition is x bar, I am going back to A itself. What should be the output?
0.
So the output will be associated with the input. If the circuit is of which type?
Sequential.
No. How many types of different types of sequential logic circuits are there?
2.
Kiki?
Milli machine or Moore machine.
Milli and Moore. What is the difference?
depends on past history and depends on past history and present information.
Yeah. So in the case of Milli machine, the output at any time instant depends on the past history of the circuit, that means the present state of the circuit, as well as the present input combination. But in the case of Moore machine, the output does not depend on the present input combination. It only depends on the past history, or that is the present state of the circuit. So if I associate the output with the X, with the input, will it be Moore machine or Milli machine?
Milli machine.
It should be Milli machine, because the output is changing along with the input condition. Input, if the output depends on the input value. But had it been Moore machine, I would have assigned the output Z is equal to 0 here. In that case, this will not be there. Only X bar will be there. Okay, this will be the only difference in the state tension diagrams between the Moore machine and Milli machine. In the case of Milli machine, the outputs will be associated along with the inputs. Whereas in the case of Moore machine, the output will be included within the state. So whenever you are in state A, throughout that the output will be 0. Whenever in state B, throughout the output will be 0. Output will be 1 under which for which state? E. So whenever you are in state E, the output will be 1. Okay, so there the outputs will not be associated with the inputs. It will be associated only with the state. So let us go for the Milli machine. Is there any other input possible?
X.
X. So if the input condition is X, that is X is equal to 1 is coming to me. In that case, what should be the next state?
B.
B.
Output is 0. If there are n number of inputs, in that case, from every state, there will be 2 to the power n branches possible. If you have n input variables, in that case, how many possible input combinations are there? 2 to the power n. For when the present state is A, there will be altogether 2 to the power n number of possible input combinations available. For every input combination, there will be one possible branch. That I am talking about the general tension diagram concept. But here, the value of n is how much? 1. So that's why 2 to the power n means that 2 to the power 1, that means 2. From every state, there will be 2 possible branches. Now from A, both the branches have been drawn. Now you are in state B. When your present state is B, once again X bar may come. If X bar comes, what will be the next state?
C.
C.
No.
You are in state B, that means what is the input pattern available? What is the meaningful input pattern or the significant input pattern available? Now only 0, only 1. The first bit 1 is available. So when I get a 0, that means I am getting a 1 0 pattern. Is it not? So the significance is this 1 0 completes the first 2 bits. So I will be going to state C. What will be the output? 0. Now I may have a 1 also. So what will be the inference?
First bit of the sequence.
stay there.
So that means
A তে
I
ফিরে
should
যাবে।
I should go back to B itself.
B তে না A তে যাবে। First
A
bit.
what is the significance of A?
No
has
bit has
first bit.
No. What is A?
No bit has been
No bit.
detected.
No bit of the sequence is available. So যখন এই নেক্সট ওয়ানটা পেলে তখন কি তোমার ইনফারেন্স তাই?
No.
What is the inference after receiving this one?
No bit
First
has been
bit.
detected.
No. A one মানে কি
First bit has been detected.
First bit. One.
So what is that state?
B.
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 So I have gone there. Okay. So now you're in state C. State C means 1 0 is available already. Now if a 0 comes, what will be the inference?
Third bit detected.
Third bit detected.
If a 1 comes,
B তে যাবে।
First bit detected.
this is the first bit of the sequence. Now we are in state D. Sorry. 1 0 0 is available. If a 0 comes, what will be inference?
No bit has been
No
detected.
bit.
No bit detected.
If a 1 comes,
Sequence
E তে
detected.
E তে যাবে। Output হবে 1.
detected. Now you are in state E and you are allowing overlapping. Okay. So if you allow overlapping and you are in state E, that means this sequence is already available. Now if a 0 comes, what will be the inference?
Second bit of the
Second bit
sequence.
detected.
Second bit টা কোথায়?
C.
C.
C তে যাবে।
If 1 comes, then
A. B.
First bit
B তে
detected.
যাবে।
B.
so that's the state tension diagram. Once you can draw the state tension diagram, your job is 60% done. ছেলেরা যা ভুল করার স্টেট টেনশন ডায়াগ্রাম করতেই ভুল করে ফেলে। After this state tension diagram, whatever job is left, that is purely mechanical job. No common sense or no gray matter is required there. But it is the state tension diagram which is of the most important in sequential logic circuit design. So once you can draw it correctly, nothing serious will be left. Only everything else is simply mechanical job. It involves only your conventional logic circuit design, nothing else. আচ্ছা, এবার আমি ওই I'll work on with this one, but I'll go back to your that 1010 pattern for শুদ্ধ সত্য. My sequence detector has to detect this particular pattern 1010. So how many states will be there? Once again,
5.
5 states.
5.
State A is once again stating that no bit of the sequence is available. State B, first bit of the sequence is available. C, first 2 bits. D, first 3 bits. E, sequence is complete. এবার শুধু as it is your problem, you have to suggest whether you will be allowing overlapping or not.
Yes, sir.
কি yes মানে allow করবে?
Yes, sir. Of course.
Fine. Then if a 0 comes, what will happen?
No bit detected.
So it will go back to state A. If a 1 comes,
First bit detected.
remember as the number of input bits is only 1, so from every state there can be at most 2 to the power 1, that means 2 branches. So already দুখানা branch আমি state A থেকে পেয়ে গেছি, so I need not bother about the state A again. Now in the state B, once again a 0 may come.
ওটা x1 হবে না?
কেন x1 হয়ে বাবা? সিকোয়েন্স কি কমপ্লিট হয়েছে?
না,
এই অবলিকের পরে 0 বা 1 সেটা কি ইন্ডিকেট করে?
কমপ্লিট হচ্ছে কি হচ্ছে না? আচ্ছা,
No.
Output.
That's the output. ইনপুটের সঙ্গে অবলিক দিয়ে যে ভ্যালুটা দেওয়া হচ্ছে, দ্যাট স্টেটস দ্য আউটপুট ভ্যালু। নাও ইউ আর ইন স্টেট বি। স্টেট বি তে আসা মানে ইনপুটটা কি এসছে? 1। এবার কি আসতে পারে? 0 আসতে পারে, 1 আসতে পারে। If a 0 comes, what will be the inference?
C.
If a 1 comes,
B or
B.
you're in state C. So what is the input pattern available? 1 0. Then if a 0 comes, what will be the inference?
A.
A.
Out of sequence. If a 1 comes,
D.
B or B set কোথায় তো যেতে পারে? স্যার B তেও তো যেতে পারে না তাহলে?
কেন?
আর কি ফার্স্ট
আমার বেস্ট সিচুয়েশন দেখবো আমি।
But we are allowing overlapping, no, sir?
Allow overlapping after what? After the sequence gets complete. Has your sequence got complete?
না স্যার।
তাহলে সিকোয়েন্স এখন কমপ্লিট হয়নি, তাহলে ওভারল্যাপিং এর প্রশ্নই নেই।
আচ্ছা আচ্ছা।
So here x with the output 0. You are coming here, that means you have 1 0 1 will give. Now if a 0 comes,
B.
E. If a 1 comes,
B.
here you have 1 0 1 0. Now if a 0 comes,
A.
if a 1 comes,
C.
C.
no,
D.
D.
হ্যাঁ D.
Okay.
Yes, sir. Yes.
Fine.
স্যার একটা নোডে ম্যাক্সিমাম কয়টা ব্রাঞ্চ আসতে পারে?
That is not because number of input branches is not restricted, but the number of output branches are restricted. output branch may be always 2 to the power n, neither less nor more. But the input branches may be of any value, depending on the my design or depending on the system requirement. সো প্রবলেম ডেসক্রিপশনের উপর ডিপেন্ড করছে কতগুলো ইনপুট ব্রাঞ্চ আসতে পারে, একটা স্টেটে কতগুলো স্টেট থেকে আসতে পারে। So that totally depends upon the system requirement. So there is no such restriction that it can have only one input branch or 2 input branch or 5 input branches. But regarding the output branches, branch out, it will be always 2 to the power n. Okay.
Yes, sir.
Next thing is we have to go for, this is called the STD. Next we have to go for STT, that is the state table. Next you have to go for the state transition table, where this state transition diagram is pictorial. State transition diagram ki ache, how the states are transiting, that I am giving some impression, I am getting some impression, pictorial impression. But this diagram will be translated into a tabular form, and that table is called the state transition table. In that state transition table, in the left hand side, I'll be having present state, present state. Okay, by the way, how many state bits are required here?
3.
3 state bits. Now, where those from the block diagram, if you can remember, from the block diagram, where this present state is available?
Output of the memory block.
Output of the memory block. So memory, it is the memory block at which stores the present state information. So কত বিটের state code আমার এখানে 3 বিটের, 3 bits. So that means I require 3 state bits, and every bit can be stored in for storing one particular bit. How many memory elements are required?
1.
Only 1. So to store 3 bits, how many memory elements would be required?
3.
3. What type of memory element you are going to use? You suggest? How many memory elements have you studied?
Latch and flip-flop.
Forget about the latches. We'll be working with the flip-flops only here.
4 type.
4 types. SR, JK, DT. Out of which memory element you are going to you are suggesting to me?
So D
Anyone?
flip flop.
D.
It will be the most trivial one, so I'll not go for that one. So let me go for the T flip-flop. T for toggle. Okay. So I'll be using T flip-flop. How many T flip-flops would be required?
3.
3. So So these are the 3 T flip-flops. T flip-flop number 1, 2, 0, 2, 1, and 0. So their inputs should have a certain distinct nomenclature. So এই ইনপুটটার নাম কি দেব?
T2.
T2, T1, T0. Okay. Now here in this set of 3 T flip-flops, where the output, where the present state is available?
Q2, Q1, Q0.
Q2, Q1, Q0. Okay. Acha, if you remember that block diagram, how many blocks were there?
3.
3. One was the output combination block. Second one was
Next state.
combination logic block. Okay. What were the inputs of output combination logic block? If we are going for the mini machine,
Present input or present state.
আচ্ছা আমি একটু সরিয়ে রাখি এটা। So what is the present input?
X.
What is the present state? The Q2, Q1, Q0. What is the output?
Z.
Z.
In the next combination logic. Oh, what are the inputs?
X.
Current state.
X are
Q2, Q1, Q0.
what is the output of the next combination logic? From the block diagram. What is written there?
Next state.
State information.
Next state information. Where that next state information was going?
Memory.
To the input of the memory. Now what are the inputs of the this memory block?
T2, T1, T0.
So what will be the outputs of this next state combination logic block?
T2, T1, T0.
Okay. Now you can understand why I have given the name next state information, not the next state. Will your T2, T1, T0 be the new Q2, Q1, Q0 value?
No, sir.
It is giving you some information about what my next Q2, Q1, Q0 values should be. But if you have used D flip-flops in place of T flip-flops, had you used a data flip-flop in place of the toggle flip-flop, in that case, these D2, D1, D0, they will be directly your new Q2, Q1, Q0.
Yes, sir.
Yes, sir.
So in that case, I could have said that the next state combination logic outputs are the next states, because the next state values are the D2, D1, D0 values itself. Is it not?
Yes.
মেমোরি এলিমেন্টটা যদি ডি টাইপের হতো, ইন দ্যাট কেস ডি ইনপুটে যে দেবো সেটাই তো নেক্সট টাইম ইনস্ট্যান্টে দ্যাট উইল বি দ্য কিউ আউটপুট। So that
Yes.
then what the new output will be, that I am creating at the present time instant itself. So the D outputs which are coming from the output of the next state combination logic block, they are nothing but directly equal to the next required Q values. So in that case, I may say the next state combination logic output is nothing but the next state. But for all other memory elements, T, SR, J, K, they should be termed as next state information, not the next state. Fine. So do you have anything to design in the memory block here?
So it is already designed.
It is already designed. So there is nothing to be designed in the memory block. But is there anything else to be designed for this sequential logic circuit?
So excitation stable.
No. The memory block part is already designed. But to complete the design of the sequential logic circuit, is it the only one that needs to be designed? Or there are two other blocks that are to be realized. Those two blocks are the output combination logic block and the next state combination logic block. So these two blocks are nothing but one particular type of sequential logic circuit, isn't it?
So these are combinational logic circuit blocks.
এত পরে কেন? পুষ্কের লেখাই আছে কম্বিনেশন লজিক ব্লক। এবার স্যার আপনি এরকম বলে দিলেই হলো যে এটা কম্বিনেশন লজিক ব্লকটা সিকোয়েন্সিয়াল লজিক ব্লক নাম দিয়ে দিচ্ছেন, বলবে তো জোর করে? So I have to design two other combination logic blocks, output combination logic block and the next combination logic block. Now for the output combination logic block, how many input terminals are there and how many output terminals are there?
4 input, 1 output.
So how many functions they have to design? Only one function that's for having 4 input variables. For the next combination logic block, how many functions have to be designed?
3.
And each function is having how many input variables?
4.
So altogether 4 Carnot maps would be required. 1 for the output combination logic block and 3 for the next state combination logic block. Okay, and 4 input variable Carnot maps are required to complete the design. Now, had you used instead of T flip-flop, had you used SR? In that case, how many outputs were required to be designed from the next state combination logic block?
6.
S2 R2, S1 R1, and S0 R0. So how many altogether? How many functions were required to be designed there?
7.
7. So 7 Carnot maps. Definitely complexity-wise, that is more complex as compared to the circuit which you are where you are using D or T as the memory element. So given a chance, you will definitely go for D type, data type. That's the simplest one. But if you are asked to realize a sequential logic function using one SR by JK, then nothing doing, you have to use them. But here we have gone for the T type of memory element. So that means the task that is left is to realize 2 combination logic blocks. Now, what is the starting point of realizing any combination logic block?
Truth table.
Table. This next, this state present table is nothing but that truth table, which is required to realize the output combination logic block and the next state combination logic block. Now, in both the combination logic blocks, what are the inputs? The inputs are the present state and present input. Present state and present input. Now, this present state is basically a 3-bit state. So the inputs are Q2, Q1, and Q0. And the present input, how many bits are there?
1.
1.
So how many combinations will be there altogether?
16.
16.
Fine.
16.
হ্যাঁ 16 মোট কটা ইনপুট হলো?
Q2, Q1, Q0 সবগুলো তো হবে না স্যার।
But when you are going for the truth table,
আচ্ছা আচ্ছা আচ্ছা।
you know that all combinations must be written. Okay. Now in the output side, I require the next state and output. Once again, the next state is also a 3-bit state, Q2, Q1, Q0, and the output is Z.
নেক্সট স্টেপ T2, T1, T0 হবে না স্যার?
না নেক্সট স্টেট তো
ব্লক ডায়াগ্রামে আমাদের আউটপুট তো T2, T1, T0।
তো ব্লক ডায়াগ্রাম সেখানে কি ওটাকে আমি নেক্সট স্টেট বলেছি ব্লক ডায়াগ্রামে?
ও না না স্যার,
ওটা কি বলেছি কি নেক্সট স্টেট ইনফরমেশন? কটা বাজে? Okay, fine. Now, when your present state is 0, 0, 0, and the input is 0, what should be the next state? First of all, is the 0, 0, 0 state available? Possible state?
No.
No, sir.
So, I am not bothered about that condition. কোন স্টেটে অ্যালাউড নেই বলো তো, ভুলে গেছি আমি। 0, 0, 0, then 0, 0, 1 is there, 1, 0 is there, 1, 1, 0, 1, 1 নেই।
Sir, 110 নেই।
110। ফাইন, বাকিগুলোতে আসে। 001, 001 is স্টেট বি। সেখানে যদি একটা 0 আসে, what should be the next state?
B.
No,
No. C.
C,
100.
100. What is the output? 0.
0.
Then 001, if 1 is available, what should be the next state?
B.
B itself.
010, 010 means state A. If a 0 comes there, it goes back to state A. If a 1 comes, it goes to state B. 001. Fine. Then 100, 100 is state C. In state C, if a 0 comes, it goes to state D with the output 0. If a 1 comes, it goes to, in 100, that means in state C, if a 1
B.
comes, it goes to state B. B is 001. 101, state D. If a 0 comes, it goes to
A.
if a 1 comes, it goes to state E, probably.
Yes.
With the output 1. Then 111. If a 0 comes, it goes to state C. C is 100. If a 1 comes, it goes to state B. So that's the state tension table. Now, from the state tension table, I can find out what my truth table for the output combination logic block is. তাই না? আউটপুট কমিশন লজিকের ট্রুথ টেবিল তার মধ্যে কি কি থাকবে, কোন কোন কলামগুলো থাকবে? Which columns of the state tension table should be present in the output commission logic block?
Present state, present
Sir.
input and output.
Output. Okay, next স্টেটটা বাদ দিয়ে বাকিটা। এবার for the next state commission logic block, is the truth table directly available?
Yes, sir.
Yes, sir.
Where do you have the output of the next state commission logic block? Do you have? Truth table means there the all possible input combination will be there, and for each input combination, what is the required output that should be there? Do you have the required output for the next state combination logic block here?
Yes, sir.
কোথায় আছে বলো?
Sir, next state.
Next state is the output of the next state combination logic block is the next state.
Yes, sir.
Yes, sir. এই যে নেক্সট স্টেট কম্বিনেশন লজিক ব্লক তার আউটপুট গুলো কি কি ছিল?
T2, T1, T0.
হ্যাঁ, শুনতে পেলাম না বাবা, একবার জোরে বলো।
T2, T1, T0, sir.
T2, T1, T0, এখানে T2, T1, T0 কোথায় আছে দেখো? আছে কি?
No, sir.
The next state is the output of the memory block, whereas the next state combination logic block is generating the inputs of the memory block. So you can say indirectly the next state combination logic block of truth table is available indirectly via the possible state transitions from the present state to the next state. So now in the next state combination logic block, the outputs of the next state combination logic block should be your T2, T1, T0. Isn't it?
Yes, sir.
Yes, sir.
Yes.
Now when the present state is 000 and present input is 0, what should be the output of the next state combination logic block?
Don't care.
Don't care, because those combinations will not be available at all. আর কোথায় কোথায়? Okay, fine. Now, when the present state is 0, 0, 1 and the present input is 0, the next state requirement is 1, 0, 0. So how does the T flip-flops operate there? The Q2 T flip-flop, the flip-flop number 2, is it toggling or not?
Yes, sir.
Yes.
So what should the T2 value?
0. No, sorry, 1.
1.
1.
What about the Q1? Is it toggling?
No.
No.
So 0. Continue with the previous state. What about Q not?
Toggling.
Toggling.
So 1.
1.
That should be the output of the next state combination logic block when the input combination is 0, 0, 1, 0. 0, 0, 1 is present state and input is 0. Present input x is 0. So in that case, this should be the required output from the next state combination logic block. The T2 output should give you 1, T1 output should give you 0, and T0 output should give 1. What about the next one? Now it should be pretty simple one.
0, 0, 0.
0, 0, 0. For the next one,
0, 0, 0.
0, 0, 0.
next one,
0, 1, 1.
0, 1, 1.
next one,
0, 0, 1.
bole jao.
1, 0, 1.
Next,
1, 1, 1.
next.
0, 1, 1. Sorry, 0, 1, 0.
তারপরটা
0, 1, 1.
তারপরটা
1,
1, 1, 0.
হয়ে গেল। সো এবার আবার চারখানা যে কার্নো ম্যাপ হবে, একটায় তোমার এই Q2 প্রেজেন্ট স্টেটে Q2 Q1 Q0 X, এই চারটে হচ্ছে ইনপুট ভ্যারিয়েবল, আর আউটপুট হচ্ছে T2 T1 আর T0। এর হলো তিনটে 4 ইনপুট ভ্যারিয়েবল কার্নো ম্যাপ, আর একটা হবে Z এর জন্য করেসপন্ডিং কার্নো ম্যাপ। সো তোমরা এটা আজকে বাড়িতে একটু ট্রাই করে দেখো। আমি নেক্সট ক্লাসে আমি এখান থেকেই কন্টিনিউ করবো, কারণ অলরেডি 12টা 1 হয়ে গেছে, ম্যাডাম মারামারি করবেন। ওকে, আপ টু দিস পয়েন্ট কোনো কনফিউশন আছে? আপ টু দিস পয়েন্ট কোনো কনফিউশন আছে?
No,
Up to the
sir.
state
No,
tension
sir.
table?
No, sir.
No,
So
sir.
up to the state tension table, it should be okay. Beyond this, there's very little task is left. I'll do that. I'll do that in the next class. Fine. তোমরা অ্যাটেন্ডেন্সটা দিয়ে বেরিয়ে যাও, কারণ কি ম্যাডামের সময় হয়ে গেছে।
স্যার ম্যাডামের ক্লাস 3টার থেকে আছে, এখন ডিবি স্যারের ক্লাস আছে।
তো তাহলে আমি এটা জাস্ট কন্টিনিউ শেষ করে 10 মিনিট খুব বেশি লাগবে আমার।
হ্যাঁ হ্যাঁ স্যার, 12টা 15 থেকে ডিবি স্যারের ক্লাস আছে, মানে
ঠিক আছে,
12টা 10 থেকে ক্লাস
তার
আছে।
আগে আমি তার আগে শেষ করে দেবো, তার আগে শেষ
হ্যাঁ
করে দেবো।
হ্যাঁ
আচ্ছা, কিন্তু আমাকে তোমরা এইটা, আমি তো নেক্সট পেজে যাচ্ছি, আমার এটা আমার কাছে তোমার কেউ কি বাই এনি চান্স নোট করেছো এটা?
Yes, sir.
Yes, sir.
ঠিক আছে, তাহলেই হবে। আমাকে জাস্ট একটু বলে দিও। when the input combination is 0 0 0 0, all T2, T1, T0 and Z don't care, তাই তো?
Yes, sir.
Yes, sir.
Then 0 0 0 1, this cell, সেখানেও বোধহয় ওই ডোন্ট ক্যারি ছিল।
Yes, sir.
Then 0 0 1 0, সেখানে
1 0 1 0.
1 0 1 0, one zero 1 0, fine, thank you, fine. তারপর একটা 0 0 1 1, this cell,
0 0 0 0.
then 0 1 0 0,
0 0 0 0.
0 1 0 1,
0 1 1 0.
then 0 1 1 0, this cell,
Don't care.
এই দুটো don't care হবে। তাই তো? এই দুটো করে
না
সেল তো
স্যার,
করতে হবে।
একটা
হ্যাঁ?
ঝামেলা হয়ে গেছে স্যার। এটা T2 T1 T0 তে একটা ও না না ঠিকই আছে।
কোনটা বলো তো?
না স্যার, ঠিক আছে ঠিক আছে।
হ্যাঁ, ঠিক আছে, নেক্সট চলে যাও এটা 1 0 0 0,
0 0 1 0.
then 1 0 0 1,
1 0 1 0.
then this cell 1 0 1 0,
1 1 1 0.
1 0 1 1,
0 1 0 1.
fine, 1 1 0 0, এটাও বোধহয় ডোন্ট কেয়ার না?
What দুটো don't care.
And then 1 1 1 0,
0 1 1 0.
তারপর একটা
1 1 0 0.
so the map is complete. Now go for the minimization. একটা এসেনশিয়াল আছে,
এরকম একটা কোয়েশ্চেনে কত মার্কস থাকে স্যার?
full 20 marks. I'm going for Q2, Q1, X plus this completes your design of the sequence detector. আর কোনো কনসেপচুয়ালি কোনো প্রবলেম আছে?
স্যার সেকেন্ড কার্নো ম্যাপে আরেকটা পিআই হবে না?
আরটা কোথায় বলো তো হবে মা?
স্যার
আমি
ভার্টিক্যালি 1 1 DD
থার্ড কলাম।
থার্ড কলাম।
ঠিক 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 হবে হবে। এটা হবে। তো আমার সুবিধা কি বলতো, আমার কেউ নম্বর কাটবে না, আমি মিস করলেও ঠিক আছে, তোমরা মিস করলে হবে না। আর কোথাও কোনো প্রবলেম আছে গো?
থার্ড কার্নো ম্যাপে আরেকটা স্যার
কোনটা বলো?
স্যার থার্ড কার্নো ম্যাপে কর্নার গুলো স্যার।
হ্যাঁ আরেকটাও হবে এটা।
ইয়েস স্যার।
ওকে, তোমরা তাহলে এবার ইয়ে তো অ্যাটেন্ডেন্সটা দিয়ে দাও, আমার রোল কল করতে বেশি সময় লেগে যাবে। অ্যাসাইনমেন্টের একটা ডি ফ্লিপ ফ্লপ আছে, দেখেছো, খেয়াল করেছো অ্যাসাইনমেন্টে?
Yes, sir.
ইয়েস স্যার।
এখানে আজকে যে সার্কিটটা প্রথমে করলাম ওইটাই ইউজ করতে হবে। সো নেক্সট দিন যারা দেখাবে ওই 5, 6, 7 আর সঙ্গে বোধহয় ওটা বোধহয় 8 নম্বর, বা আমি ভুলে গেছি কত নম্বরটা, ওই ডিপ ওটা দেখিয়ে দিও।
ওকে স্যার।
স্যার নেক্সট দিন কি রোল নাম্বার 80 পর থেকে শুরু?
হ্যাঁ, ওই বোধহয় প্রসেনজিৎ মন্ডল অনওয়ার্ডস।
ইয়েস।
ওকে, তোমরা অ্যাটেন্ডেন্স দিয়ে বেরিয়ে যেতে পারো।
থ্যাংক ইউ স্যার।
ওকে,